and remember we did scarp execute, print program output. Now here is what I wanted to show you. If you look at your folder back again, you have scarp.toml, you have src, and in that you had your lib.cairo and hello world.cairo, right? But you can also see now a folder has been created which is called target, and that target has like an executive folder that has the execution product, like the execution result, right? Now what do we do once we have executed? We go back and how do we verify this execution, right? How do we firstly prove, how do we generate the validity proof for this execution is, what you do is scarp prove proof. Can you guys see? I'll just clear the screen 1 minute. Clear. Okay, much better. Zoom in a bit as well. Close this. Okay. You have to do scarp prove proof and hyphen execution. Now because if you can see in this project folder under target, under execute, your execution is termed as execution 1. Okay. So we are going to prove this execution only by saying execution ID 1. Now if you can see proving counter.
Oh, look at that execution.
Yeah, this one, yeah. Now see, a validity proof has been generated that basically you can use now. So if I do, if you are you guys following along?
Yeah, so I put scarp proof execution ID 1. And it gave me proving counter at 1. Soundness of proof is not yet guaranteed by STW.
Yeah, that's fine. That's a warning, yeah.
Error, prover input file does not exist.
Did you give space between ID and 1?
Yes. I'll figure it out.
I think I'm sorry. What was the first command after? What was the first command here?
It's this only. Scarp proof execution ID 1.
Scarp group? Yeah, exactly.
It's an S proof and there's something covered.
No, it's scarp.
Scarp space proof.
Scarp space proof. Okay.
Scarp space proof.
1 minute.
Execution.
I'm just gonna fix this. Yep. Execution ID 1.
Warren, soundness of proof is not yet guaranteed. Excellent.
Yeah, that's because it's just a very simple program, right? So they cannot guarantee like what is happening in the program is, but they are generating proof that this program was executed, and this proof we will verify that it's using scarp verify hyphen. It's called execution ID 1. So wait. Why did I do I like this?
So the file is execution 1 inside execute / whatever
Wait.
counter app.
Ooh, okay. Yeah, if you can see verifying counter, verified proof successfully.
Mine is not giving successful, but I'm
Let me see.
wondering whether execution ID 1 is so scarp proof execution ID 1 gives this error, and then if I look at this
Does not exist at execution 1 prover. Okay, wait, see.
So here it is, just a sec. It's called execution 1, and maybe I should just. Okay, I'll figure it out. Patika, you continue. It's no point waiting while I figure this out. This I can. You know what?
Yeah, I will debug that for you right after we finish this because
Debug.
we do not really have.
It will tell you what. You can AI your way out of this.
Yeah.
The
So
commands for sure. But it's like the idea is understanding what it is.
it's getting verified here using this command. So anytime that you are running a program, it's scarb execute, scarb proof, and scarb verify. Okay, execute will execute the program, proof will generate the validity proof, and verify will validate the validity proof, right? Okay, the three commands. Now moving on, what I wanted to talk about was data types and then
Verify will verify the validity proof.
yes,
Scar proof will create the validity
the
proof.
yes,
And execute will run it.
yes.
Okay.
Execute will execute the program altogether. Right. So are we ready to move forward?
Yes.
Okay. So firstly, I wanted to talk about the data types that were in that are present in Cairo programming language. The first one is fed. Oh God. The first one is wow. None of them work. The first one is felt 252. Now this was the default type of Cairo. What is felt 252? Felt literally stands for field element, right? It stands for field element, and it is similar to an integer, but it has some different properties, especially how arithmetic operations work. Okay. Now, what are arithmetic operations? Addition, multiplication, division, and subtraction, right? So, addition, subtraction, and multiplication work the same way, but when you, in fact, even division works fine. But when you do this, what happens is when you wrap around, like, what I'm trying to say is the arithmetic operation. If we do the division or percentile, right? This is the remainder. Like this is division, right? And this is remainder operation. These will basically cause you issue because felt does not have like overflow support. Okay, what I mean by overflow support is, let's say a variable you put in your inputs and now is overflowing, which means it requires more characters than like more bytes than that is assigned to this, right? So this will still get executed without overflow protection, and we're going to look at how that works. Let me show it to you here on screen. So here's the thing, right? What is happening is the modulo for every type of computation, it will always wrap in any operation which is usually not what you expect in code, because balance from whether it's division or whether it's remainder, right, is going to let's say, for example, like what I mean by that is, like, for example, if 4 divided by 2, you know it's going to be 2, right? Or 4 modulo 2 is again, it's going to be 4 modulo 2 is going to be 0, right? Because we're looking this operation is for remainder, and this operation, like 4 by 2, is for division, right? So this operation or this operation, when you know the output, that's fine. But what if it was 4 divided by 3, right? It would come again in no, it would come in pointers, right? But this is again when we now 4 divided by 3 is going to be some small number with some points, right? But what about some number divided by some number that's going to result in an overflow? Felt does not have overflow handling. It just gets executed when it should actually not execute and throw an error, right? That's the reason the default type of Cairo, though it is felt, is not much used. We only use like U32 or U64, U128, u256 like. So the second data type is unsigned integers. It starts with u8, and then there's another one, signed integers, which starts with 8, right? Let me show you something else.
You said I8 for sign?
Yeah, this is
Okay.
signed integers. So it ranges all the way from I minus 128 to plus 128, right? When you do I to when you move ahead on the numbers. So next up we have, what did I want to say? Yeah. So in U you have till U256, but in I you have till 128. I also you have till 256, but it's from minus 128 to plus 128, right? And it's 128 here. Okay. Now these are this is one of the data types again that we're looking at. The next data type would be, and before we move on to data type, I will show you how it's panicking and where it's throwing an error, right? Let's just get into programming a bit, so it's easier for me to also explain. So firstly, I'm going to remove this, and we are going to add.
You're using WSL, right?
Yeah.
It's
Mac.
not working because of various patches required. I get it. She's going ahead, but those errors that are coming
Yeah.
are because of WSL.
But I haven't.
The Scarp.
No, it worked. It worked for
on
him.
my end,
So
but
because
I've been playing around with Linux for a little bit now, and I've
he didn't
installed
install it right now, so that's why.
I had the dependencies from earlier, but I had messed up on other projects. I'm trying to just conceptually understand. I just
Yeah,
follow
yeah.
it. So when you need us to build something, you'll tell it. Yeah.
Yes, I am going to like just write files here and then create another file to explain to you what is the difference between felt and U32, because I talked about overflowing and stuff, but let me just show you in real life how that would work, right? Otherwise we could have gone further, but I feel like that requires some. 1 minute, I created it in the wrong.
And everything you're doing here right now, this is all in Cairo language,
Yes.
which you're saying it's the same principles as all the other programs. You have to spend a few days reading the documentation, understanding why, like which is the JSON file, which is the ENV file, which is the source.
Yes.
That kind of those same
Yes.
elements. Okay.
Yep. So
So,
I'm defining a test here.
so all you've been explaining so far. Sorry, fundamentally, it's just you're kind of just concepts of what these like commands and what these syntaxes are. You're kind of you're setting the stage and building the blocks.
Yes.
Okay, good. So I trying to see the bigger picture and. Actually, I'm gonna run to the bathroom.
Yeah, go ahead. I'm just going to type this out, and by the time you guys you come back, I'm gonna.
So these monitors work. I can just bring my window.
Yeah, that could work.
This WSL has its own.
Yeah, that's why Windows is not such
I'm
a.
not pro WSL. I should have bought my Ubuntu. I made a mistake. I didn't think. Because I don't have a monitor. It's a small mini PC. So I didn't know whether it would work. I'm very good. It takes it's not taking a minute. You don't need to go. Now that I get it. So tomorrow, hopefully, viewers have to take those photos that what's his name has requested. Yeah.
Oh, sorry. What's happening here? Okay, right now division trait is not implemented only on felt 252. That's why I'm getting this error, if you can see. Right, I wanted to show how overflow works on felts and stuff, but because of the new updates and stuff, right, they removed the division operation from felt only. So now you cannot perform division on felt, division or modulo, which is the remainder operation on felt anymore. That's why you use U32. Okay. Now moving on to, we did functions and I explained you how functions work. Another data type that I wanted to tap into was what do we do for strings, right? Now strings, usually you can use them like you can use a alphanumeric value for in felt 252, but sometimes we also use something called as short string, which is again its value is a felt 252 only. Or if you want to do like a long paragraph or something like that, then we go for something called as byte array, bytearray array. Okay, and that's it does not have any limit to the size of the string. All right. Now moving on to functions, here's something that you need to, an important point is, like sometimes you might see, for example, I write a function and I say hello baby, okay? And this is a function and it says it is returning U32. It can also return felt 252. Like I said, this is just the return type. And here if I am just saying 5 and just stopping it like that, right? This is still a valid function, and if you do not put semicolon in the end, that means you want the function to return that particular value. Okay, it's the same like how it works in Rust. So if you don't put a semicolon, then it means that the function is so that particular line that does not have the semicolon is basically getting returned as the function output. Okay. Now next up something and this type of return is called implicit return. Which means implicitly it's defined that this is how you return it. Now when you explicitly use the keyword return, because another way that you can write this is by saying like this, return 5 semicolon, right? This is explicitly returning a value. That's a keyword right there. Okay. Now moving on to bigger and better things, which is the integers. Like we learned about both signed and unsigned integer, right? And there for u it's all the way up to 256, and sometimes in a little bit of how do I say this, in some developers you might use, you might see are using something called as u size, okay, as a data type. U size is nothing but U32. It's just another way of writing U32. Okay. So if you find a code, a legacy code, or maybe a developer that's using U size, right? It basically means nothing but U32.
Okay.
Yeah, that's the data type right there. Okay.
Is it the Wi-Fi network hasn't changed for any reason, right? I'm connected, but I'm not getting Wi-Fi. I'm not getting internet. Like it's showing I'm connected, huh?
Sometimes.
Yeah.
Sometimes it happens.
It's connected. I'm just trying to.
Okay, so an important thing to notice for signed integers, like I said, I256 does not exist. It's I128 only, because it's minus 128 to plus 128. Plus, there is no such thing as I size. Okay, it's only for the unsigned integer bit where you are using U size for U32. I size is not I32. There's no such thing as I size. Okay. Then next up, what I would want to do is operations like that. Okay, perfect. Now we did see addition, multiplication, division, subtraction, right? But how would you do complex mathematical operations? Like for example, square root. I love how this keeps falling.
Shift it a bit.
Yeah. So, how would you do square root? Or how would you find the power of something, right? Because sometimes we use star and stuff, right? In some programming languages like JavaScript. But here, how would you find the square root of this thing is? So there are existing libraries in Cairo that you can use. We are going to see how we can use existing libraries, right? You just go on to Google and then you type scarb.xyz. Now this is like the npm package manager website where you can find packages that you need to run your project. Wait, it's not scarb xyz, it's scarbs xyz. Scarbs. Yep. Yeah. It's Scarbs XYZ. This is the Cairo package registry. So let's say you want to perform the power or square root, right? So if I check for square root, I will just type like this square root. It wouldn't give me anything, but like mathematical, you will have to like search specific libraries, go into them, see which operations they're performing, right? Now, the operation that we are looking at is this Alexandria _ math or Alexandria.
I happened to get lucky with that non-guess one. That was something I had before.
Yeah.
Wi-Fi are you using?
Bitcoin Way.
Xiaomi accessory.
The biggest 15.
50.
That's right.
No, it's not 50, it's 5.
It's fine. I was on that one, yeah.
Okay. It's Alexandria _ math.
Are you using VPN?
So if you can see, it has a set of math operations. Now, the beauty of the documentation, like I said, people, you can literally read the entire documentation. You can see which one you want to use, what's happening. Even there's a function called ispr to verify if it's a prime number or not, right? To find out if it's an Armstrong number or not. The whole bit mapping can happen. There's so many functions, including an algorithm for Fibonacci itself. Rather than defining, you just call the package LCM, perfect number. Now the two that even for SHA-512 and EMD 160, they have the mathematical operations right there for you. Right, this library, in my personal opinion, one of the super important libraries. Now we're going to look at the math operation that I was talking about, which is now how do you import this library into your project, right? We read the documentation, it's pretty, but how would you put it? So you either run this command, but what I'd like to do is most of the times just come into scarb.toml and under dependencies just copy and paste this basically, this part, which is the easiest, copied, and then you're pasting it here. So this is under dependencies, you're adding this package for your project, right? That's most of the times the errors occur because your packages are not rightly defined in scarb.toml, and then AI is just going on and about how your program is completely incorrect and stuff, but it's usually a package installation issue. Okay, next up, now in this Alexandria.math _math package, what I wanted to show was how we can do advanced math operations. Like I said, it has a very beautiful documentation, different math operations that you can run. In fact, remember we did Fibonacci. I just did a Fibonacci, but it has its own, like the Fibonacci algorithm itself is defined, and you can just call it using a single command, right? How do you use this package in your, in here is, wait, let me just get back to that file. Okay. Wait. I will talk about what this is in a bit when we are doing smart contracts, but just give me a second. Okay, usually all the tests that you're running stays under one module which is called tests. So I'm just going to copy this. I'm going to delete this in fact, and then go ahead and just define a test where I am test. I am going to write advanced math. Okay, and I want to calculate the power of an integer. So we're gonna define a again using let a u32 equals 4 semicolon, and I'm just asserting to find now. Now if you read this documentation, you will go down and read about fast power. This is the algorithm that is used to calculate the power of a given number, right? Now we have imported alexandria.math into our project, but how do we use this fast power? So that's when at the top, just after opening up your modules, what you do is you use the keyword use, and then you say Alexandria underscore math colon fast underscore power colon, and then call it fast underscore power. Okay, so this is basically your package. You're going into your package, and then you're going into the library that has defined the algorithm, and then you're using the function of the algorithm. Okay, you're getting what is happening here? So you're calling it here fast underscore power of, let's say, a comma to the power of 2, which should be equal to 16. Now assert is like a comparison. It's asserting. It's usually used like a print statement, but also it also calculates and checks, verifies, right? So that's why we are like, for example, here I am asserting that the fast power of a comma 2, which is 4 to the power of 2, would be 16, right? And I am using it through the library. Like, I do not have to define a power function in itself where I'm telling, multiply this integer multiple times. I'm directly using a package importing, and that's what I wanted to show you, how to import packages, how to use
So if you were to go to the command line and test this, how would you, what would the output be? I just want to kind of see what, right?
What?
What are you going to get?
You have to do scarb execute, but then I do not have any function that would get executed, right? I only have tests. So right now I can do scarb test, and this test would be performed, and it would just say test passed 1, and then test failed 0. That's it.
I see.
Yeah, because these are tests that I am showing you on how to run this, right?
I see.
Getting my point?
Getting your point.
Yes, perfect. Okay. Next up, I wanted to show you how. So I am just skimming through things because I want you to be because this is a builder sprint, and I want you to understand just the fundamentals so that you are able to pick up everything on your own, right? Now,
That's right.
yes, the next thing that I wanted to talk about was the process of casting. So we talked about data types, right? Now let's say a data type is U32. How do you convert? If you are converting a smaller data type into a larger data type, then it's very easy. You explicitly, there are two types of castings. So typecasting is nothing but converting a variable from one data type into another data type. And because this is a strongly typed language, you will have to perform typecasting explicitly and implicitly, right? So how would you convert? The first one is let's say you have a U8, okay, and you want to convert it into a U32. Like you have a variable with the type U8 and you want to convert it into U32. How would you do that, right? So there is something called as, there's a function that's try underscore into and bracket dot unwrap. Yep, and then, so let's say we had a colon U8 equals to 10. Now, when you are converting any smaller type, like the one with the smaller size, right, into a bigger size variable, it's usually easy because the bigger size is already accustomed to, it can accommodate the smaller size variable, right? You're getting what I'm trying to say? Like a smaller variable with a smaller data type. Why do we use U8? It's 8 bits to store a variable, right? To store an integer, unsigned integer. So when you want to convert it from 8 bits to 32 bits, it's usually easier because 32 bits already can store an 8-bit this thing, right? But what's harder is converting 32 bits to 8 bits. Like how would a variable that is using 32 bits be stored in 8 bits? So, but this is the function that we use. Okay, let's say we want to convert A to U32. We will do this. Say double equal to is basically going to assess whether what we are talking about here in this function is the same as what we are writing on this. It's like equation, equating it to the value, right? So if you say, let's say 10 underscore U10, this is U32. Right, 10 underscore U32. This is another way of declaring instead of like writing like this, right? You can also declare it this way, U underscore 10 U8 U32. Like I'm talking about definition. We said, right, A colon U8 equals to 10 is how we declare a variable. There is another way to declare a variable by adding an underscore and writing U32 at the end. That's explicit declaration. So how would you explicitly declare here 10 underscore U32? This function will convert, like will unwrap A, which is a U8, into a U32. Okay. Now, why we are talking about casting so much is because when a smaller type, when a larger type is converted into a smaller type, there's a high chance it might overflow, right? Like you're getting my point. Like if let's say, okay, I will show you exactly what I'm talking about so that you. Let's say our storage space has only. Let me see. We just have like 8 boxes here, okay? I'm just going to take an example of how U8 and U32 works because I feel like you're not able to like fully understand what I'm talking about. My markers are drying up. Yeah. U8, right? So let's say we have 8 boxes and then we have 32 boxes, okay? Just assume, okay? This is U32. Why is this not working? Is it right?
No, those markers may be old.
Yeah, they are.
Just throw them out. Otherwise, you're going to keep using them.
Yeah.
Okay. U32. Okay. So it's basically like having 8 boxes of storage and then 32 boxes of storage. Now, when you are converting this 8 boxes of storage to 32 boxes of storage, it's very easy to accommodate because 32 boxes also have 8 boxes in them, right? And they can easily, like, the contents of these 8 boxes can easily be put into the first 8 boxes of the 32-bit, right? But what if you had a variable that required 32 boxes and you wanted to convert it into 8 boxes? How would you do that? Because the first 8 obviously would get accommodated here, but then remaining, you know, the subtract 8 minus 32, you will get 24. The remaining 24 bits is overflowing. That's what overflow is. So how would you like tackle this overflow is what we're going to talk about, and that's the whole reason I brought up casting in the first place is
Okay.
because of this.
Okay.
Right? There,
Casting means what?
casting means converting it from one type to another
Got
type.
it.
That's
That's
it.
okay, got it.
That's it.
That's the concept.
So yeah, so there is something called as result and option in Cairo, where basically, wait, let me turn this on. There's a result, and it's called the result and option, right? So what happens is, let's say we wanted to find an even number. I'm just gonna call this function find even, okay? And then I'm gonna use x as u32, return. Now here I can return an option. Option is like a custom type. Because we have this overflowing, because from converting from bigger to smaller has this overflow, how do we tackle this is through options, right? Now I can return an option of type u32, and then I open it. I'm saying, like, how do we check if the remainder with when you divide it by 2 is actually 0? That's when you, so this, let me just write this, then I will explain. Sum of x else option what?
You did, and then it's doing some.
So option is like how you are giving out multiple. It's literally as the word suggests, right? It's like giving out multiple options. So you can give any option here where you use the keyword sum, and then you say what you want to do with x, and then you can use the default option would be none, right? When it's not satisfying your needs. So for the result enum, what is basically difference is these are basically enums, which are like your custom variables. Its option is an enum, right? And for result enum, it's used for different purpose, but similar. It has like two different members, and the difference is it allows you to define an explicit error message when it fails. So what I'm trying to say is basically, look at this. Like, I'm just going to change this to what you see there. So you know what enums are? Nitin, can you tell us what enums are?
Kind of like predefined like options.
What do you mean by predefined options?
So let's say like there are like some status of your like package like delivered.
Yeah.
So you can choose that in your program, like code that in your program, and it can be updated. So order received, like
Exactly. The result enum is what we are getting into. So let's say we want to have a result of the program, right? There are two. How would you display this result? There can be, the result can be success or the result can be error. So that's where you primarily we are using this option enum, where you can explicitly give return the result message as well, right? You can return an error message. It's okay if not able to like fully compensate enums, because like I said, we're trying to like
These are concepts to thread
yes,
together.
yes,
yeah.
to thread together what's happening. Now, how we use Alexandra math, right? Let's say I wrote some functions out and I declared some variables outside of this particular module, right? How do I use everything, like import everything you have in some of the languages, right? There's a keyword called super, This is what I like to do specifically, because sometimes you might have visibility issues because public and private variables exist, right? Where you do not want somebody to read those variables, or and sometimes errors might happen in your program just because your program is not able to read the value of that specific variable. How do you solve that error is by using the keyword super and then : start, like this. Okay, this will import everything, all the public variables that are visible outside of your module into your module. Okay, next up that I wanted to talk about was, I actually want to talk about the structure of how a smart contract worked, which is very important for us. Yep. Because we're going to be writing smart contracts, and that's the main reason that we want to be doing this, right? So I'm going to talk about traits and everything on what?
Start that. You start that now?
Yeah, I'm just going to give you an overview, and then we're gonna, like, I'm probably going to do a recap of what we did today so that we have better.
Yeah.
I wanted to
So
show.
tomorrow, the goal is to
Build a counter app by the end of the
build a full DApp. Yeah.
full D app with front end, back end, or just show you how you can implement the front end, because that's pretty easy.
Yeah.
But to show you how a smart contract structure works essentially, right? Where we are, because the beauty of especially a Starknet smart contract is there is a skeleton, right? You do your step 1, step 2, step 3, step 4, step 5. If you miss any step, that's where the error occurs. As long as the steps are all there, you can build multiple functionalities on the steps, but the skeleton of a smart contract is the same, right? How do you do implementations? How do you do traits, etc., etc., etc.? So that's how this works. So that's pretty much it. I think we can wrap up, and then I can do a recap tomorrow morning where I show you how smart contract, because it's getting late, as well as, like, I'm pretty sure we're not in the learning mindset anymore, because a lot of I feel the sugar rush has hit us, so that's why.
Sometimes, okay, that's not bad.
Yeah. So that's what our
I'm all pepped up, ready to go finish before tomorrow morning and give you a full smart contract.
go ahead.
Watch me do it.
No, and my goal is not to teach you how to code, or how to, like, build.
The basic, the rest we have to take on.
Exactly. And tomorrow I'm not
going
gonna spoon feed anyways, but tomorrow I'm going to show you the skeleton of the smart contract, right?
Even these, like, these are these are all not variables. These are like concepts.
They're concepts. Yeah.
They're concepts you need to put together to be able to see.
Yeah.
And even
Even read the error
even
message,
the concepts
right?
are hard to understand until you see the picture, right?
So here's the
it's like
question
you're
for you. The smart contract we build tomorrow
Okay.
will be our choice of a smart contract, or you're going to tell us what to build?
Tomorrow I'm going to show you how to write a smart contract for a counter application.
And from there we need to take
Like, you can take on, and there are, like, problem statements that I was talking to the foundation about, and I'm going to, like, pitch it to
So
you.
here's my question. When you write a smart contract for a counter application,
Yeah.
where does